Okay, let's explore the function that is given with formula y is equal absolute value of x. So based on definition of absolute value, we have absolute value of x, it's going to be equal x if x is greater than 0, 0 if x is equal 0, and negative x if x is less than 0. Sometimes we can use the following notation also, like absolute value of x is equal x if x greater equals 0 and negative x if x is less equal 0. And the other notation also you can write down, y is equal x if x greater equals 0 and negative x if x is less equal 0. So any of this notation is valid and you can use any of those. Okay? All right. So now let's see how will look the graph of x when x is greater or equal 0, and how will look the graph for x when x is less equal 0. So here we have okay. This is one graph, and the other this is negative x. Y is equal negative x when x is less than 0. And now I will show the graph when x is greater equal 0. There we go. Two different graphs. Okay, so this one is x less equal 0, and this one is x greater equal 0. So then the graph of the function y is equal absolute value of x, it's gonna look like the following way. Okay. So then this is gonna be absolute value of x. Okay. All right. Now let's talk about properties of function y is equal absolute value of x. So first property. This function is defined for any and all real numbers. Okay, the function is defined on for any real numbers, which means we can write down it's defined between negative infinity, positive infinity. This is what we call the domain. value of x. Okay. Second property, the graph can have only non-negative value. Okay, only non-negative value. So, which means it can be 0, which that's going to be our range. Let me write down here. Only not negative, non-negative. See, it starts with 0, right here, and goes up, the value of y. So it is going to be 0 and plus infinity. Now, 0 is included, right? Therefore, we put square brackets. Square brackets always shows that that value also included. At the infinity, we always put in parentheses because infinity doesn't have end. Therefore, we never put square bracket around infinity. It's always going to be parentheses. Next property. The graph is decreasing on the interval. Here is decreasing, right? From here coming down. Yes? And it's coming from where? From negative infinity. This is negative infinity. This is positive infinity, right? For our x. So it's decreasing from negative infinity till 0. And we include 0 also. And increasing also. So it's, let me see. Decreasing and increasing, because here it is, it's increasing here, right, graph, and that's when our x is going from 0 to infinity. Yes, so it's increasing from 0 to positive infinity. Okay, increasing. All right, the fourth property, the function is even. The function is even. Why? Because f of negative x is equal f of x. Such function is even because here we have what? Absolute value of negative x is equal absolute value of positive x. I think it would be more proper way to put, I'll put this one first. And this one will be kind of conclusion. So hence we can say if absolute value of negative x is equal to absolute value of positive x, hence we can insist that the function is even. All right. Okay, number 5, the function is continuous, right? Okay, and it's continuous on interval from negative infinity to positive infinity, right? Okay. And why is it continuous? Because there is no interruption on this graph, right? All right, let's build the absolute value of x with its shifting. So it's going to be y is equal absolute value x minus x0 plus y0. Okay. So first, let's build the graph y is equal absolute value of x minus 2. So first, before we build the graph absolute value x minus 2, first thing we have to do, build the graph absolute value of x. All right? Okay. Let me expand a little bit. So if this is going to be my absolute value of x, then minus 2, it's going to be, I'm going to shift, it's going to be same, have same x. Let me put this whole point here. Okay, then minus 2, it's going to be shifting down by 2 points. Let's say 1, and this is 2. This is 1, and this is going to be 2. So this one is absolute value of x, and this one is going to be absolute value of x minus 2. Okay, next we are building y is equal absolute value of x plus 3. So it's going to be first, again, we are going to build absolute value of x. Oh, that's not what I wanted. Okay. This is my absolute value of x, and I don't think I got kind of too much angle, I think. And this one, well, let's use imagination. Okay, so, and then I'm moving up by 3. 1, 2, 3. On the y-axis. Okay, so this is going to be absolute value of x plus 3, and this is absolute value of x. All right, next one, we are going to build y is equal absolute value x minus 2. So how it's gonna look like? So first we are going to build again absolute value of x as always. And what is interesting here, since we have shifting x going at by negative 2, that means we have to move by positive 2, 1 and 2. Why is that? It has very simple explanation. So when we want to find out, let's say here, we want to find out the shifting of y, because in this case minus 2 is a shifting of y, right? We always take x is equal 0, and you get shifting of y. When you want to find out shifting of x, then you take y is equal 0. And you are getting x minus 2 is equal 0 and x is equal 2. And this is where from x is always going to be shifted to the opposite direction. And y, it's going to change it, shift it in the direction it is given. Negative 2, then the y will go down by negative 2. If y has plus 3, then move up by plus 3. Unlike x, if x is given x minus 2, it's going to go towards positive 2. So let's build it. Okay. There we go. So this is, it's going to be absolute value of x minus 2. And this one is only x. All right? Okay. Let me clean drafting so we can have it a clear picture. Now let's do the x plus 3. Y is equal absolute value x plus 3. So in this case, this is my absolute value of x. And I'm shifting by negative 3. 1, 1, 2, 3. Okay? Well, looks like, oh, hold on, what am I doing? I apologize. Okay, negative 3. And here, going to be positive, to the left, to the right, and now to the left. Okay? There we go. So here we have absolute value of x, and here we have absolute value x plus 3. Okay? Let me clean this a little bit so it's getting, there we go, much better. And this one also I will rewrite. Okay. All right. And lastly, I'm going to build the both cases included in this in one example. It's like going to be y is equal absolute value x plus 1 and minus 3. Okay, let's build it. Okay, so first let's build absolute value of x. Next, you can do either shifting of y or shifting of x. Doesn't matter. So I'm doing shifting of x. So it's going to go by negative 1, right? Here we go. So it's going to come here, parallel, and here. Okay. And now this is negative 1. And now we're going to move down by 3, right? So from where is 3? 1, 2, 3. So if I bring this because our vertex is going to be at -1, so it's going to be -1 and 3, right? I'll write down after I draw the graph. So it is going to be, I'm going to draw now parallel to x plus 1 graph, and it's going to go, and x also. There we go. This is 1. And this is 2. So this point, this vertex is going to be -1, -3, right? Okay, because this one is -3. So what do we have? This is our absolute value x plus 1 minus 3. This one is absolute value x plus 1. And this one, as we know, is absolute value of x. I hope I made it clear for you. You understand, and you will remember this because you understood. All right. Thank you for watching.